There we go. Okay. So, and everybody knows you got to have a graphing calculator. You had to have one last year, so you better still have it. They do rent them out from the library, but if you come to class and you don't have your calculator and we need it, now if we don't need it, who cares? But if we need it that day, then you will have to rent one from me. So it costs you 50 cents. You'll rent a calculator for the period. So just go to the library and get one, or bring your own. Preferably just have your calculator with you all the time. Why would anybody go anywhere without his calculator? That's the question I have. Okay, number 1 in our note sheet. Find the decimal form of 15/8. Oh, that marker doesn't work. Find the decimal form of 15/8. What do you think? Anybody have an idea? How do you convert that to a decimal? Divide it. It's a division problem. So 15 divided by 8. Some of our work will be calculator, some will be no calculator. So this I would expect you to be able to do without a calculator. I'm not going to ask you to do 12-digit division without a calculator, but this one you should be able to do, so you know what to do, right? So 8 goes into 15 once. Bring down to 0. Like, give me some kind of facial clue that you know what I'm doing here, and that you're not like in La La Land. Okay, 8 goes into 70. I'll get the fog out. 8 times. Shoot, 8 goes into 60. 7 times. Finally, 8 goes into 40. 5 times. This is called a terminating decimal, because even though we were a little bit worried about it, it did eventually stop, right? That's called a terminating decimal. Any terminating decimal is an example of a rational number. A rational number. You guys talk about those before? So if it's a terminating decimal, it is a rational number. All right, negative 11/6. Can I do the same thing? 11 divided by 6?
Yeah.
Oh, 6 into 50. 8? 6 into 20. 3? Uh-oh, this does not look good. What's going to happen?
Repeating decimal.
It's a repeating decimal. This is an example of a repeating decimal. Guess what? Repeating decimals are also rational numbers. So any decimal that terminates or repeats is called a rational number. If the decimal terminates or repeats, it's rational. So what would irrational be? Well, an example is pi. Why is pi irrational? What's special about pi? It never repeats and it never terminates. So it's an irrational number. Can someone, that's the most famous one, it's our favorite one, but can anybody think of another irrational number? There are gazillions of them. This is an irrational number. This is an irrational number. This is a rational number. So this is rational because it's just 2.0, 2. These are irrational because if you work them out, they would go on and on. It would never stop. Now, you might be thinking, wait, Miss Ford, if I type square root of 2 on my calculator, it stops. Does it really? No, you just run out of room, right, on the face of the calculator. So these are irrational, along with pi. These are all irrational. There is also one more really famous irrational number. Did you guys do logarithms last year?
Yeah.
Okay, did you do natural logarithms? That is LNs? Didn't do those? Okay, well there is, I'll just tell you right now, there is a number called E, and we'll talk more about it when we get to like chapter 3 or something. It's Euler's constant, but it is another very, very famous irrational number. Okay, good. Number 2, everybody still with me? Describe and graph. All right, let's say you're taught Christian's absent. He doesn't know the videos are available, so he calls you up and he says, hey, what are we doing in math class today? Because I'm sure he's worried about that. How would you say this to him over the phone? Oh, we looked at an inequality, and the inequality we looked at is what? How do you say that? X is greater than 3. X is greater than 3. And you all know that what that means is, on your number line, we're going to put in open circle at 3, and we're going to shade this way. If, oh, I'll wait, you go do the next one. We'll talk about the next one. Everybody okay with that? It says describe and graph. This is all the numbers bigger than 3. And that, by the way, isn't just 4, 5, and 6. That's 3.5, 4.2. That's every number bigger than 3. All right, how about this? This is called a compound inequality because there's 2 of them. There's 2 inequalities there. What do you think about that? Could you graph that, Jacob?
Put -4 and 2, and -4 has an open circle, and then -2 has an closed circle.
Everybody good with that?
Mm-hmm.
And then where's the shading? In between. In between. Okay, these are concepts you should be pretty comfortable with. Now, you'll notice that I'm not putting a 0 on my number line. I'm not putting a bunch of hash marks. You don't have to do that. Plot the numbers that are in the problem. Now, if you want to put the 0 and all that in, that's fine. But you don't need to. This is perfectly fine. Okay? Now, I want to talk about something that maybe now you didn't talk about last year, and that is a different way to write this problem. As you go farther in your math career, actually, the very next step, which is calculus, you probably won't see things written as inequalities. You'll see things written in what we call interval notation. This is interval notation. And in some ways it's easier, because you don't have to worry about the signs, you don't have to worry about the lines, all of that. It's just -4 and 2. Now, this symbol, the parentheses symbol, stands for open, which means when you graph it, the dot is open, which means the symbol is not an or equal to. This symbol means closed, which means when you graph it, it's a closed dot, which means in inequality form, it's an or equal to. Every inequality can be written in interval notation. So let's back up to this one. Now, remember, I gotta have 2 numbers in there. I only have 1 number on my number line. What do you think the other number will be? Not 0. Infinity. I heard somebody say it, infinity. Because what are we graphing here? We're graphing 3 to infinity, right? Now, what do I put here? A parentheses or a bracket?
Parentheses.
Parentheses. Infinities are always parentheses. And the logic there is, it's kind of theoretical, but the logic is, can you get to infinity? No. So you can't ever color it in, you're never there. So we're just going to always make our infinities parentheses, always. All right, so let me get to the next one. And it is already in interval notation. This is not an ordered pair. It looks like an ordered pair, like x comma y. but it's not. It is an inequality, it is an interval. So how would you graph this on your number line? Oh, I gotta watch the time. Otherwise, we'll just stay here and talk about math all day. Let's finish this problem. What's this gonna look like? Got a -1 and a 3, right? They're both open, and we know they're open because we have parentheses, and then we're gonna color in between them. So if we wanted to write this like this, it would look like this. Yep.
I'm not a space but how do you know the color in between them?
Always. We always color. Yeah. When you put something in an interval notation, here, 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 you put those two numbers on the number line and color in between. If one's an infinity, you arrow it in. All right, guys, I'm gonna start putting the work in school. These are probably things my son again. Check it out, see? Check it out.
We love first thing.
And I say, always color in between the two numbers, whatever they are. Have a good day. See you tomorrow. Where's my see you tomorrow? We didn't finish it. This is just not.
You put your stuff on the wrong side.
My advanced class. This is not.
I'm gonna put this stuff is right there. Rashawn told you wrong because the desk is right here.
Okay, Solomon, your job is probably going to be the